Now I'm just going to start sharing my screen. Give me a few seconds. Okay, so you should be able to see my screen shortly. What I'm going to do, here locally I've started Elasticsearch and Kibana. In the very basic setup, we can start Elasticsearch just by running Elasticsearch bat file, and similarly for Kibana. No additional security setup, no additional configuration, just bare bones Elasticsearch and Kibana. Once those two are started, we can go to the Kibana dashboard at default port, which is 5601. After a few seconds, once we start Kibana, we can go to the developer console. One of the most widely used tools from Kibana that allows us to do pretty much anything with Elasticsearch. So what I'm going to do here, I'm going to create an example Elasticsearch index along with the mapping. I'm going to insert some data, and I'm going to show you how we can query that data using the various Elasticsearch clients. Now, what I do here in Kibana, we can simply do it also through the Elasticsearch clients that I'm going to show you. But for simplicity, I'm going to insert the data directly here from Kibana. So the index I'm going to create is called order data. It contains a number of fields, such as description, order date, proper serial number, shipment date, quantity, vendor, unit price, excluding VAT, and so on. So this index might represent some order data that we might have. Also, as part of the settings section, we configured the number of shards and replicas for that index. As we know, it's a good practice that we plan the number of primary shards upfront before the index is created, because that number here is changed quite difficultly when we start adding some data to our index. So that's a matter of good upfront planning, and the number of replicas might be changed along the way more easily. But for now, I'm just putting some defaults with 5 number of primary shards and 5 number of replica shards for my index. I'm going to execute that through the developer console. Here I can see that the index is inserted in Elasticsearch, and it's been acknowledged in my current instance of Elasticsearch. Now I'm going to add some data to that index. We have a number of ways we can use to add data. I'm going to show you just briefly 2 quick ways we can do that. First is by putting a single document in that index. So here what I do, I just call a put the index. This lowercase doc previously in older versions of Elasticsearch was the type of the document, because documents in an index were logically separated in types, but that was effectively deprecated. So now here we just put doc, and then the index of the document I would like to insert. I have a number of ways I can specify that index. If I don't put anything here, Elasticsearch would create that for me. I can also use a custom strategy to define how this index is generated, or generated through my client that I'm using for interacting with Elasticsearch. But now I'm just putting here an index of 1, and I'm putting some sample order here that is going to be inserted in that index. I just execute that, and I can see that the document is created with a version of 1. If I want to put a document with the same index, the version would be incremented. Elasticsearch provides versioning of documents, which is quite nice. Use different versions of the same document. And if I want to insert more records, a more convenient API I can use is the bulk API. So I've pre-created request that inserts a number of records in the index. And the bulk API is under the post index name bulk API. Here under different lines, I specify the different types of documents that I insert. On the first line, I specify the ID of the document that I'm going to insert, and on the second line, I'm specifying the actual data for my document. And here I'm inserting 9 more documents in my index. So if I select that and I run that index, so it tells me that for each document that I try to insert, it tells me that it's effectively created in the Elasticsearch index. Now, having inserted a number of records in that index, I can query it from Kibana, of course. So I can say, for example, get order data search and perform any search request I would like to perform. The simplest request I can do is a match all query that just gives me all documents in the index. If there are more than 10 documents, I just get the first 10 documents, and I can use pagination by specifying additional query parameters from the search request to return more documents. So here, if I execute this match all query, I can see that I get all the documents that I've inserted in my Elasticsearch index, which are a total of 10. Okay, so I've created my sample index. Now, how I can interact with Elasticsearch in that particular index through Java. So Elasticsearch provides two standard clients for Java, which are called low-level and high-level REST clients. They can be added to the project through the corresponding Maven or Gradle dependency. So for the low-level REST client, I need to include Elasticsearch REST client dependency. And for high-level REST client, I need to include Elasticsearch REST high-level client dependency. And it's good here that I specify the version of the client version that matches the version of Elasticsearch I use. In that particular case, I'm running Elasticsearch 750. And here for the REST high-level client, I'm using a slightly newer version of the client, which works with 750. Once I add those dependencies to my project, I can start using the client. A very brief example of how a low-level client looks like. I create a REST client instance, which comes from the low-level client dependency. It provides a builder pattern that allows me to specify the Elasticsearch host, which I want to execute a query. In that particular case, I specify just local host on port 9200 for Elasticsearch. So once I build that client instance, I create a request. A request is represented by another instance, which is provided by the org Elasticsearch client request class. I create a post request to search the order data index. And here in that request, I can call a method to set the proper body for that request. In that particular case, the low-level REST client allows me to specify bare bones JSON that is executed as part of the request. So I call the set JSON entity method, and I specify a match all query. Here, of course, we can use our own Java model in combination with Jackson or a different JSON processing library that allows me to not construct this string here as part of the JSON entity method. So that's perfectly fine to do. And once I construct this request, I call perform request method on the REST client coming from Elasticsearch, which simply invokes the request and returns the response. And the response, I process it by converting it to string and just printing it out. Again, here the response might be parsed as a Java model that I have, and I can work with it accordingly. But here I simply get it as a string and print it out. So if we run that simple enough example, just to see what happens. Once the client runs, I can see that I get the records that I inserted earlier from Elasticsearch, a total of 10. And they're returned simply as a string. So as a JSON array that I get from Elasticsearch. Now, that's good, but in many cases, that's not very convenient, of course, as we need to construct JSON here. For that reason, we can use the high-level REST client, which provides a higher-level set of abstractions that we can use in order to interact with Elasticsearch. We can use the high-level REST client in a similar manner as the low-level REST client. The methodology is pretty much similar and the same. So we create an instance of REST high-level client, and we specify on which Elasticsearch host we want to connect to. Then we create a search request on the other data index, which is a higher level instance class than the one provided for the low level client. Then we create a search source builder, which in fact implements builder pattern and allows us to build the query using the various utilities provided by the high level REST client. In that particular case, I call the query method and I specify a match all is available from the query builders class. So the query builders class is very convenient as it provides me the possibility to specify different kinds of queries using the various methods such as match query, match phrase, and different kinds of search requests I can create using query builders. So in that particular case, I just specified match all query, which is the simplest possible one. Then I set that search source builder on the search request, and I call client.search passing that search request, which is executed from the client to the Elasticsearch instance, which I have on localhost. Then I can iterate very nicely through the results. I call get hits because the results are returned under this hits block. And then I call once again get hits to return an array of all the results. And then for each result, I call the get sources string method to return the result as a string. So I'm in fact doing the same thing as with the low level REST client, but just using the high level REST client. Now, if I run that example, it will simply give me the same result as with the low level REST client. So I'm getting the results one by one and I'm printing them as strings. So far, so good. So, however, many projects that want to integrate with Elasticsearch are based on a higher level framework, such as, for example, Spring. And if we want to create, of course, instances of those low level or high level REST clients, we can create our own bean method that returns an instance of any of that clients. And effectively, we can create a managed bean that corresponds to a client for Elasticsearch using low level or high level REST clients. However, under Spring Framework, we have a few nice projects that further simplify the process of interacting with Elasticsearch. One of them is called Spring Elasticsearch. So Spring Elasticsearch is hosted under GitHub. It's a community project, not officially under Spring Framework, but it currently supports latest versions of Elasticsearch. What Spring Elasticsearch provides is a convenient way to create low-level and high-level REST clients by adding additional capabilities, such as, for example, creating additional mappings or indexes while creating the client or adding more properties to the client. In order to use Spring Elasticsearch, we need to include, of course, dependencies in our proper dependencies in our build configuration. In that particular case, I add the Spring Elasticsearch dependency, which comes from that group, frp-latu spring. And once I add that dependencies, I need to create a configuration class. In that particular case, I create a configuration for REST high-level client using Spring Elasticsearch. To do that, I create an instance of Elasticsearch REST client factory bean, which is the main utility provided by Spring Elasticsearch. Using that factory bean, I can set a number of things. I can set the number of the particular Elasticsearch nodes for to which I want to connect. I can also set mappings, and here I specify a list of indexes to be created in Elasticsearch. For each of those string indexes, I can specify in the resources of my application JSON files that correspond to those indexes. And what the factory bean does is that it gets the information for the mapping from that JSON file and creates it in Elasticsearch once an instance of the REST high-level client is created. So that's pretty convenient if you want to pre-create some indexes or create indexes using some index templates, for example. Because otherwise, if you want to do that, you have to do that as a separate initialization part of your application using those clients. So that's pretty convenient. So using that factory bean, then we call the getObject method to get the generated high-level REST client instance and use that. Once we provide that configuration, we can simply inject an instance of our REST high-level client. And using that, we can perform a search request as we showed earlier using that high-level REST client. For example, in that particular case, I'm creating a match-all query using this injected instance of REST high-level client created with Spring Elasticsearch bin factory. If I run that example, as expected, it returns the same results as using the high-level Elasticsearch client, with the possibility to pre-create additional indexes and provide more configuration as part of this Spring Elasticsearch configuration. And last but not least, a further layer of abstraction we can add is if we, for example, have already a Java model that we want to use in order to create our indexes and to query those indexes. Here comes in handy Spring Data Elasticsearch Framework. Spring Data Elasticsearch Framework provides the possibility to make use of the Spring Data methodology for interacting with Elasticsearch. In order to use Spring Data Elasticsearch, we need to add the corresponding dependencies. Spring Data Elasticsearch is an official Spring project, and the group ID which I need to use is org Spring Framework Data. Once I add that dependency, what I can do, I can create one model class that represents my index as a Java model. So that class is annotated with this document annotation that comes from Spring Data Elasticsearch, which specifies the name of the index for which this Java model corresponds. And then I define the different fields which correspond to the document fields of that index. I also annotate one of those fields with an ID which corresponds to the document ID, because in Elasticsearch, every document has a unique ID, as we know, and I can annotate that with ID annotation. I also have a few other, but I'm not going to use that throughout the demo. That's the very basic model I can use for my index that I created earlier. Then I can create a repository, a Spring Data repository, which should extend from Elasticsearch repository. And I specify as a first argument the model that corresponds to my index. Then I create two methods. One is find by serial number, which Spring Data Elasticsearch is able to generate based on the naming convention of that method a query against Elasticsearch that gets me all the documents that have that serial number. And if I want to create a custom query, I can use the query annotation from Spring Data Elasticsearch and specify in pure JSON what's the exact query that I want to execute against Elasticsearch. In that case, that's a match query that pretty much does the same thing as find by serial number method, but using a custom query. Now, in order to use that repository that I created using my Java model, what I can do, I can simply inject that repository as part of my application and call the corresponding method. In that particular case, I can just call find by serial number. And that's all I need to do. As you can see, it's pretty concise, but that's driven from the Spring Data methodology. And another thing I can also use from Spring Data Elasticsearch is to inject an Elasticsearch REST template client that allows me to perform operations at a lower level against Elasticsearch using that template class. So if I run that example, I can see that here there is a request performed, and I'm getting the description of the document that has this particular serial number of which I've specified here as the method argument. I can see pretty much that here document returned, which corresponds to an order for Windows 10 Pro laptop, which has that serial number. And as you can see, I didn't have to write any particular Elasticsearch query. That was done for me behind the scenes from Spring Data Elasticsearch. So that's pretty much To summarize, we saw how we can use the standard low-level and REST high-level Elasticsearch clients. Older versions of Elasticsearch use a now deprecated transport client, which you should be discouraged to use. And if you use Spring Framework, you can also use as an additional helper the factory provided by Spring Elasticsearch project, or go straight away with Spring Data Elasticsearch, which is the highest level of abstraction available in Spring Framework to interact with Elasticsearch. Now, we have a few minutes for questions. You can ask any questions in the chat. We've been notified of some delay. I'll just stop my screen share. So if you have any questions, just ask. Okay, there are a couple of commands that, I can try with resources in the examples. The examples I've shown you might be improved in a number of ways. These were just very straightforward, simple examples to demonstrate how we can interact with Elasticsearch. So yeah, of course, we can provide a number of improvements there. For the source code, yes, I'll provide you with a link for that. I'll put it on under my GitHub account, so you can find me under GitHub. My account. I just need to log in shortly. You can find me as Martin FMI under GitHub, and I'll put the examples there shortly. Okay, any questions in regard to interacting with Elasticsearch, the clients that I've shown you, or any other topics related to interacting with Elasticsearch? We have 2 or 3 more minutes, so please go ahead. In the meantime, while think of some questions while we have a bit more time. So as I mentioned, it's good to keep in mind that using the different clients, you need to make sure that they are compatible with the version of the Elasticsearch or the ELK stack that you use. Otherwise, you might get into situations where even though the client might work, at some point in time, it might be a single API that performs in an unexpected way. So it's a must that you use the corresponding version of the dependencies for your deployment of Elasticsearch. And of course, there is a lot of capabilities that I didn't show you during this session, which you can explore using the various clients for Elasticsearch. And you can just play around with the clients. They are very rich. All the things that you can do in Kibana, you can also do them through the Elasticsearch clients. So yeah, I just encourage you to play around with the various clients. If you use Elasticsearch, see what would be the most convenient for you to use. So I'm going to share here my profile in the chat. I'll put the examples shortly, so you can use them. Okay, I think we are out of time. So I would like to thank you for the attention. And yeah, you can catch up with me, find me on GitHub, LinkedIn, or any other means, and just ask me for any Elasticsearch related questions if you have any. I'll be happy to answer and help. So have a nice day and enjoy the And yeah, you can catch up with me, find me on GitHub, LinkedIn, or any other means, and just ask me for any Elasticsearch related questions if you have any. I'll be happy to answer and help. So have a nice day and enjoy the. And yeah, you can catch up with me, find me on GitHub, LinkedIn, or any other means, and just ask me for any Elasticsearch related questions if you have any. I'll be happy to answer and help. So have a nice day and enjoy the rest of the conference. Bye.
Hi everyone. Thanks for joining us today for the blazingly fast websites using Azure Static Web Apps and Azure Functions presentation. My name is Martin Kuf, and I'm going to now to drive you how you can create really fast websites with the built-in functionality of Azure. And not so much of that we'll be talking about Microsoft technologies today. Actually, we'll be talking about JavaScript and Python with the help of GitHub workflows. So just in brief, because this is a short presentation after all, I just want to give you a short introduction what it's all about. We have something that is called static websites. These are websites which have static resources only. They have HTML, JavaScript, and CSS, nothing else. Unfortunately, we cannot put any server-side code in the static websites up to now, until at least. And the benefit of using static websites is that they can utilize global content delivery network, which is in short CDN. And with the help of global delivery network, our content can be much closer to the end users, and this way can be delivered much faster. Some examples of hosting platforms, global platforms for hosting static websites are GitHub Pages, Azure Blob Storage, and Azure Static Web App that we are going to see now. The downside, as I told you, with GitHub Pages and Azure Blob Storage is that they cannot host any server-side code. So you can only host your static resources. And today we're going to see how you can host your server-side code using Azure Static Web App and its integration with Azure Functions. So Azure Static Web App provides hosting of static files, as the name implies, and it uses the global CDN content delivery network from Azure, which has, I don't know, at least a few tens of data centers all across the world. You can also use custom domain to set up access to your website, which we're not going to see today. And you can set up a free SSL certificate that gets renewed automatically. So whenever the certificate expires, it gets renewed for you. You don't have to do that. It also has a built-in security and authentication so that you can authenticate your users. And also it has role-based authentication and integrated security for accessing the resources. Then we also have server-side routing. That means that you can specify routes in a JSON file where you want to redirect each resource to. And the most important thing that we're about today is integrated API with CI/CD. So what does it mean, API? It means that we can host server-side code within the static website. It's actually not hosted in the static website itself, but it has a pretty good integration. And when you deploy a static web app with API, it creates Azure Functions for you on behind, which you can securely call with integrated user and role-based authentication. It also has seamless routing, so there is no need for cross-region request routing to be specified. And it supports Azure Functions version 3. However, keep in mind that it's still up to date. The integration with Azure Functions API supports only Node.js, .NET Core, and Python 3.8 at least, at most. I mean, All right. So with that, and for one last thing to say about Azure Functions is that you can also implement Azure Functions with its built-in support for HTTP triggers and bindings. That means that your API can be called by a HTTP post request, and it can bind to some storage sources like Azure Blob and other Azure resources. So before going to the demo, let me just briefly tell you what the CI/CD actually means with Azure Static Web Apps. It supports when you create an Azure Static Web App, it will automatically create for you GitHub workflow. This workflow will basically take your static website and the included API, will build the website and will publish it to a location in Azure. Then you can access it, as we discussed, with integrated security and built-in authentication. When you have some changes to the repo, the integrated work will create a new staging environment for you. And then after you're done with your changes, you can merge all of your code to the production environment. So this all comes built in for you, and it's pretty cool. That's why I decided to show you. Keep in mind that Azure Static Web Apps is still in preview, so we don't know how much it will cost. Supposedly, it's not going to cost that much, just because that it will use Azure Static resources like Azure Blobs. So can pretty much be confident it will be much cheaper that you can actually host your website on a WordPress hosting or something like that. So in the demo, what we're going to see today, we're going to create a static website using GridSum, which is a framework based on Vue.js, and we'll create the static web app in Azure. Then we'll create an Azure function in Python, and we'll call the Python API. And we'll see how the whole CI/CD story works. All right, so let's go to the demo. I'm just going to. So first, I will open a command prompt, and I already have GridSum installed. GridSum you can find here. Sorry, just a second. Find GridSum installation here for gridsum.org. And after you get that, all right, we'll go to my small shortcuts here. We'll go to my other drive. We'll go to the repo sites folder, and then we'll create a static website, which I will call static web app demo. With the built-in with the GridSum CLI, I specified I would like to create a GridSum project based on the GridSum starter briefly. It's a starter project that has some built-in pages, so we can see the benefits of using GridSum immediately. You can find it here. It's pretty useful to get some initial idea how GridSum works. So let me go back to my command prompt. Here I will create the static web app demo, and I will specify the Git repository where it can download the source files. It will take some seconds. Let me just close this browser that's been behind. All right. I'm sorry, my machine got pretty slow, but that's due to, I guess, due to the streaming. I'll just open this so you can see it. All right, so now it goes and clones the repo, and it will put the project, it will create the project in this static web app demo folder. So everything I need to run the static website will be there. The static website does not have any API, Azure Function API yet. We'll add this additionally. Let's see how this will go. It's getting pretty slow though. All right, while we wait for this, I will go now and I will go now in GitHub and we'll create a repo. I'll create a repo where I can push my new project. And this will be static web app demo repo. Edit public. And we'll just go and create the repository. Okay, so now I will need to, in my folder where I create the project, I will need to add the origin repo. Oh, it's still sitting here. Oh, this one is pretty slow. Then what I'm going to do now, I don't know why is it so slow. It was not supposed to be that slow. Let me fall back then to something that I already did. Okay, so here I have this static website demo. I create it. No, static demo 2. Have my Gridson project already created. For some reason, this one gets extremely slow. So in here, I have sorry, and remotes. I was looking for remotes. Okay, so this one now points here, but I would like to new repo. So what I have now is the Gridson project, which I'm going to push to my new repo that I just created. And I'll make this as a origin 2. Just get different, so we can be sure that this goes to the right repo. Okay, then what I'm going to do now is git status, so we can see that all projects are checked in on branch main, and now I'm going to push everything origin to main, and this should fill all my Gitsum static website. It should push it to the repo I just created here. All right, so here it is. Now it's not really functional because the project, it has the source files, but it's not built yet. So what I'm going to do now, I'm going to create a new static web app, and I'll come here. I have my resource group here in Azure, and I can create it with by selecting static web app. All right, so create. You can see it's still in preview, so there's no pricing yet announced, but you can use the functions as they are. So I will name this static web app demo, and I'll select that I want to be hosted in West Europe. It will use the content delivery network, but still as a web app where it will be hosted, I choose to be in West Europe, and you can see still the static web apps are still in preview, so the number of data centers that you can select is pretty limited. So in here, I need to authorize with GitHub in order for the static web app to access my repo. Okay, I'll give it control. And now it will allow me to select GitHub organization and then repository, which we just created, and that was static web app demo. And I select branch main. So with build presets, I select that I want to have a custom preset, and in here I select that the app is located in the root, the API is located in the API folder, and then artifact location. This is something that we're not going to use, but I'll just put this here. Create the web app now. And with the click of a button, we have the web app created. So it will take just a short amount of seconds. Until then, I'm going to close the previous window that did not complete. It completed now, but okay, I'll just leave it as it is here. So the static web app is now created. I'll go to the resource. You see, it was pretty fast. And in here, I can open this URL. And I can see that, hopefully, yeah, my static web app is live and waiting for your content. That's because the static web app is here, but nothing is hosted yet. So what we need to do is actually make sure that the GitHub workflow has completed. So I will go to my repo here, and in Actions, I can see there is a workflow created for me by the app, and it's now building. It's now working with all the steps. So you get this integration with GitHub automatically. You saw that I did not do any actions or workflows created here. It was provided for me by the static web app in Azure, and it's now building and completing the job. It will take just a few short amount of seconds. Until then, just because of lack of short time, I will proceed now of opening the project with Visual Studio Code. See how my computer goes then. I apologize for the slow response here, but obviously screen sharing takes too much resources on my computer. So this is the Gridson project that I have. And now what I would like to do is to create an API. So basically, what do I need to do now? While we wait for the job to complete on the back, I'll go here on the command palette in Visual Studio Code, and I create Azure Functions, you need to have Azure Functions add-in plugin installed to Visual Studio Code. When you have it and when you open the palette, type functions, and it will create, it will show all the different possibilities to use, different options to use functions. Then we will create a new project in here in Visual Studio Code. It will take some time. To initialize and show me the options of how I can create my Visual Studio, my Azure function. Okay, so it says now choose a folder where you want to create the Azure function, and it's here. And I want to use Python. Remember, JavaScript, Python, and C# are supported right now with static web apps. So I select Python. And I can select a version of the Python interpreter, which will supposedly show here. Okay. And I want it to be triggered by HTTP request. So this we will name something like HTTP trigger 1. Let's not be too creative here. And authorization, I will create a function level authorization. That means that my site should be able to call that function. I don't want to override this. No. Okay. This should not happen here. Actually, these files should have landed in a different folder. Okay, but let's give it some time. The thing is that these files should have been added to the API folder, which somehow I missed to create in the demo. But let's see. So in here, while this is creating a Python virtual environment and preparing my project, I'll come back here in the workflow, and we can see that this is now completed. So my static website should be built and published now. And I can go here and just refresh the page, and we can see this is the initial project, the template project that I used, which is called Briefly, and this is the result of calling it from static web apps. If we get the the page tools now to see how fast page speed tools. See how fast the website is loading. I can give the URL here, and also let me remind you that these URLs that we have published the static web app here can be customized, so you can use your own. And using the page insight, you can see how fast this website is responding. It's pretty good index, right? Because it's only static. I'm sorry, it's only static web page. So what we have published the website. We have a CI/CD that will take care of new changes automatically, and we'll publish them. And last thing I'm going to show you for briefly of shorter than 5 minutes, because I'm really going over my time. I will try to fix this mess that I've created just now with the API, because we need an API folder. Or maybe I can just start it over from scratch, and I'll just say discard all my changes. Just that it's so slow now. Okay. So we don't need this. This is a virtual environment for Python. Now we should not have any changes. All right, so let's try this again. Let's give it one more try. And no. I need a folder here, which is called API. And within this folder, which should be selected, and it's pretty kind of tricky here, selection, because it's empty. And now let's try to create a new project. Select the folder that will contain, well, okay, well, probably I need to browse it. Okay. Now Python, then again the Python version, when that shows up, okay, HTTP trigger 1, and authorization by function, and now let's give it a second. Okay, so here it is. Oh, good, now we have all the sites, all the files for the Python Python API created in the API folder. It needs to be API folder because when we created the CI/CD, we explicitly said that when we created the static web app function here, not the function resource here, we specified that we want the API to be in the API folder. This can be changed actually if you go to the actions and you can view the workflow file that was created for us, and in here we can see that we can change the API location if we mess this up at some point. Anyway, let me now see the coolness of the CI/CD. Okay, why is that this started here? Okay, let's see what happened now with okay, so no, it's not running, it was just cache. Let's see what happened here. It's creating virtual environment. It's creating a lot of files. It should be ready within a minute, something like that. So what I want to do now is to push all my changes to region 2 because it just created the API. And actually within the API, I will just leave it as it is, simple as it is, just to, we need to pass it a name, and you can see this is a Python code. We can pass a name in the query string, and it will print out the name back to us. This is the whole function. But we just want to make sure that we can now call it from the static website. We can call the API, integrate it with security and all the stuff. So let's try to publish this Azure function. So what we need to do is I'm now going to create a new branch, because this is how new changes should go to the region site, right? Create a new branch, and I'll check out all these two serverless. I'll name this serverless because Azure functions, are basically serverless technology. So you can see here I'm now in the serverless branch, and I will stage all these changes. And then I'll say serverless as a commit message. I know it's not very meaningful, but let's go ahead. Okay. Now I need to push it, and I just want to make sure that I will push to origin 2, because remember we created a new origin because of the initial slow project creation. So at the moment where I push this, it will go to my repo, and then nothing will happen actually at that point of time. But let's wait for a second just for the push to complete. Okay, it's done now. And as you can see here, if I refresh the page, everything is good. The action is not running, but we can see on the code section that there is a serverless branch was pushed, and we can do a pull request. So with the pull request, I can say, okay, now let's create a pull request to main. And just by clicking create pull request, the static web app bot will kick in, and it will start some checks, GitHub checks for me. What it's going to do now, it's going to build the static website with the new API I've just created, Python API, and it will create a new environment, staging environment, where I can see the changes. It will take a very short time. This is running on the server, not on my computer, so it will be much faster. So I just want to show you the initial URL that our project was published. It was at mango-c-0a blah, blah, blah. So when the pull request, when the check completes and the pipeline, the workflow kicks in, it will actually create for us a new URL where the website is hosted, which will serve as a staging environment. At some point when we merge the pull request to main, then this staging environment will be destroyed, and we can be safe that nothing's left behind. Also, additional benefit is that you can add more commits to this pull request. If you got something wrong or you want to improve the pull request, then the Azure Static Apps workflow will be kicked in again and again, and you can see the changes on the staging environment. Okay, so let's do a refresh to see if it's actually done. It should show automatically, but for some reason it might not be refreshed. Okay, so it's still working. We can see the details actually. You can see that it's actually has checked out my branch, and it's now building and deploying everything. There's a lot of information inside, so I'm not going to spend time on reviewing that, but it should be ready pretty fast. Let's wait for it here. We'll give it some time. Any questions, by the way? Okay, so there is some delay between receiving questions and me speaking, so I will wait for a few more seconds for questions while the CI/CD is running. Let's see how it goes. Okay, so it's almost done. In the back, this job is using something that's called Oryx build agent, which actually makes sure to publish the static website and the functions API. Okay, so it should be more or less done any second now. Okay, so here it is. All checks have passed, so the project has been compiled and published successfully, not compiled, published successfully. And within, as you can see now, just at the moment we have a new environment. There's a Git Actions bot, which provides us with a new staging URL. Please note the -1 here. So within here, we should be able to see our API. So this is the static website again. But the API, the API itself is located here, which is API./HTTP trigger. I think we named that. Let's see again, one more time. API HTTP trigger 1. And we need to pass a name like Martin. And boom, hello Martin. This is HTTP trigger function executed successfully. Python function, we should explicitly say here. So this is a Python function that we can now call from our website without any course issues, because it's the API is hosted on the same URL, as you can see, as the static website. So at some point when, as I told you, at some point when we are happy with everything we have done, we can merge the pull request back to the main branch, and a new CI/CD will kick in, and this new environment will be destroyed, so the changes will be here. At this point, they are still not trigger. They're still not available here. Let me copy this. But they will become available. Okay, so we will not be waiting for this because I'm pretty much out of my time. So yeah, as you can see on the production environment, the API is still not here, but it will get there as soon as the CI/CD. I'm sorry, CI/CD on the main branch actually completes. All right, so that was it. I hope that made some interesting thoughts on your mind on how to implement static websites with serverless technology in integrated API functions. So I will wait for a minute now to wait for some questions and eventually to compensate for the delay in the presentation and streaming. Thank you. Thanks, Nicoletta.
So it's going to start in about 10 seconds, baby. So I'm curious to see how many people are going to be there. I'm still waiting for the audience to start coming in.
Okay, so they're not like strict.
They had some technical difficulties.
Okay, I can go here.
Okay. So guys, I'm waiting for the audience to start coming in because it's still the three of us.
I guess you can start.
I don't see anybody in the people section.
You only see the moderators, so the audience
all right.
is hidden.
All right. So sorry for the delay, people. I thought I was going to see a list of the participants. So it is one day before Christmas, and we are here thinking and talking about code. I don't know what this says about us, but I am happy that we are here. Today I will be talking about writing good code. Writing good code that many people are talking about these days. And I hope you can see my slides already. Let me do a quick check. Yeah. Writing good code is something that many people are talking about. We are writing good code here. We have to be writing good code. Okay. But why are we pairing these two words together? Writing code. As if writing code is some really special activity. I don't think it is. The important thing here is that we are writing. We are writers. And we are not the first people in the history of humanity to be writing. There have been many others before us that make their living by writing. Authors, journalists, contract writers. They have been doing it also for far longer than us, and we can learn from them. This is why the title of this talk is Code as Prose, means written language, Lessons from Our Colleagues. A little bit on that tune also. Why is programming, not with us that are programmers, but in the general audience, why is it associated with math? Oh, if you want to learn to be a programmer, you must be good at math, people say often to each other. But how many times have you been annoyed with your coworker because they are not good at math? Me, zero. And how many times have we been annoyed with them because they write messy code? Very often. So, code. Code, according to the Cambridge Dictionary, is a system of words, letters, or signs used to represent a message in secret form. So code is something that we do when we want to hide something. And truly, indeed, it seems that many times that's exactly how some code is written, with the intention to hide rather than to show, accidentally, of course. Only when we move down to the fourth definition, we see that code also means a language used to program computers. That's not a very encouraging beginning, huh? And it can get even worse. According to Martin Fowler, any fool can write code that a computer can understand. Good programmers write code that humans can understand. That's quite harsh. That's quite harsh. Is there any hope for us, mere mortals? Well, no one in the brief history of computing has ever written a piece of perfect software. It's unlikely that we will be the first. This is a little bit better. But why is it important to write clearly? Do we have any project managers, agile managers, or generally non-programmers with us? If so, please write +1 in the chat section. I'm very curious about that. I was also informed that we have a 30-second delay, so let's give it some time. So write +1 in the comment section if you are not a programmer. For the rest of us that are programmers, we are looking at a chart that shows what we already know very well. Look at the green part of the pie chart. This is the amount of time that we use reading code. Like, what was I thinking when I wrote that? Oh my God, can it really be that? Oh yeah. And then we change a few things here and there. We check that we didn't break anything. Once in a while, we might even get to write something completely new. But mostly we read things. This is the bulk of our activity, the most time-intensive activity. So if we want to become more effective at our jobs, this is where the most gains are, at the green part. If the code is hard to understand, then we are making our most common activity harder, and that's truly a waste of time and money. All right, this is common sense, and most of us know it. If we want to write well, what do we have to pay attention to? We're going to start looking at some points, 9 to be precise. Have there been any managers with us? No one so far. Point number 1, length. The length of our writing. Blaise Pascal, the French mathematician, wrote a letter to one of his friends at 1658. I am sorry, he tells him. I have only made this letter longer because I have not had the time to make it shorter. I think we can all relate to that. And think of that paradox, huh? We did a lot of things because we did not have time. Of course, you're in a hurry, you have to reach the deadline, the funding deadline. There are 100 more tasks waiting. You just blurb out 100 lines. It works. It's okay. If you had time, you would look at it again, you would make it nice, but you don't. And so you move on. Let's see an example by using my own code. This is some code I wrote some time ago. On the left, you can see the first working version. On the right, you can see the final version. Let's remove the clutter a little bit so we see reality clearly. On the first version, we can see that I start well. The structure of the two pieces is pretty similar. I start out well, but at the end I derail in some blubbering. In the final version, the code is both shorter in line length, but also in column length. It's more compact, and everyone would prefer to work with this one. It's much better. But it happened because I gave it the time it needed. I didn't stop just because it was working. Don't stop with your first draft. This is a quote from an amazing book called The Elements of Programming Style. And as the title implies, it deals with how to write clean code, nice code. It's, I think, one of the first books, maybe even the first book of this type to be published. It is a classic, and I recommend it to everybody. There's also a little funny story about how the quotes of this book are included in my talk today. I included them after I had finished with the presentation. I thought, wait a second, there was that book that talked about good coding. Maybe they have something to say about these topics that I make in the talk. And I was amazed to see that they had something to say about each topic. Usually something identical with the topics that, with the comments that other types of writers are doing. So I paired these quotes up, programmer to programmer and writer to writer. So don't stop with your first draft. And what I find fascinating here is their choice of words. They don't say, don't stop until it's working. Of course, it is expected that it's working. We are beyond that. They say, even if it's working, it's still not done. It's a draft. Keep working at it. Point number 2, intro. Intro is a term that comes to us from journalism. In journalism, they use it to describe the introduction to a news article, the first paragraph. It briefly describes what happened, the what, why, how, when, and who of the story. It briefly gives you all the essential information. What do we have in programming that is supposed to do the same, to let us know what follows further in? It is the method signature. Method signature, as we all know it, identifies a function by the method name, the number, types, and order of parameters. I would also say for some languages like Java, the return type as well. Let's see some good and bad examples of functions. This example is written in PHP. Function calculate that gets as input an array. This gives us no info. Somebody would say, yes, but if you were writing in Java, it would be much better. You would know the type of this argument. Well, not really. It wouldn't really much be clearer. The function name could still be very generic. The name of the argument could still be very generic. And even if the argument was an array list of something, this something could even be something with a very bad name. How can we do better? Of course, we can be more clear. That's better. So we calculate the sum of some depths, and we get as a result an integer. But let's imagine for a moment that for our imaginary case, we can do even better. This function not only calculates, but maybe also saves the sum. Now it is accurate. Now it's good. So our friends from the Elements of Programming style say, use variable names that mean something. Use statement labels that mean something. Give the reader information. Don't force the reader to go through everything in order to understand what's happening. Give a good intro. So all types of writers are concerned about how to give the most amount of information in the least space possible. That's not something that only programmers care about. What else are we suffering from besides bad function and class names? Another concept that we worry about a lot is repetition and redundancy. Let's see what other types of writers have to say about that. What is it, first? Redundancy is the act of using a word that repeats something else and is therefore unnecessary. There is a fine line between repetition and redundancy. Repetition can be good, can emphasize your writing. Redundancy, on the other hand, cannot be good. It just restates what has already been said, takes up space, and gets in our way. What do we programmers say about that? We have the dry principle. Do not repeat yourself is a principle of software development aimed at reducing repetition, replacing it with abstractions, and using data normalizations. So every other writer, we are also concerned about redundancy. We do not want unnecessary things. And we are very cautious about repetition too. We try to state things only once. And of course, if we are not dry, we are wet. We are wet. And wet means write every time. Write everything twice. We enjoy typing. Or the irony that I love, waste everyone's time. That's so true. And why do we waste time? We know that because the code is just longer and because when we have to change something, we have to hunt down all the instances of this repetition. And of course, we'll forget something. And of course, we'll create a bug. How to avoid it? We know that very well for a very long time. Replace repetitive expressions by calls to common functions. By the way, some cooking books, recipe books, know that very well. If you don't know how to create, for example, an egg mix or a dough mix, they refer you to the appendix that in the proper page you can find these instructions. So we're not the first people to have discovered these functions or abstractions in writing, definitely not. Other types of writers have also been troubled by how do we refer to a common operation. Now, a little bit more about the dry principle. We talked about it in the context of code that repeats itself. It does not deal only with code duplication. There is another excellent book, The Pragmatic Programmer. There they say, dry does not only mean don't copy and paste code. Dry is more general. It's about the duplication of knowledge of intent. It's about expressing the same thing in two different places, in two different ways. This can refer to, for example, duplicate data in our databases, data that exists both in a database and in some external service, and sometimes we look for it here and sometimes there. Logic that is both in the front end and the back end, this dilemma. Where do we put this validation? Let's put it in both places. Or even in the way that we structure our directories. This is a pet peeve on mine. Every time I see this, I get a little bit nuts. Look at this. A directory called controller that has inside three, oh my God, who would have guessed that? 3 controllers. Well, if truly the name of these files is 1, 2, and 3, then the prefix controller is unnecessary. 1, 2, and 3 is fair enough. This is not only redundant, but also confusing, inconsistent. Why is this directory controller not called source controller? And why are the files not called source controller? Why are we repeating ourselves only once? This is redundant and inconsistent. So be aware of redundancy in many levels. Number 4 issue, polarity. This is something that also concerns writers. Polarity is used, of course, in magnetism and electricity to denote positive and negative, but also in grammar. Polarity in grammar can be either affirmation or negation, and has to do with whether we say something in a positive or negative way. For example, I am away from you guys. We're doing this online. I am away is using affirmation. I am not close is using negation. I am not close. Be positive, not negative. Hemingway, that by some is considered to be the best author of the United States, had this quote. By the way, do we have anybody from the United States here? If so, write +1 in the chat section. Hemingway suggests that we say the following phrases. Don't say, the laptop is inexpensive. Don't make me think. The laptop is cheap. Don't say the operation, the procedure is painless. The procedure is comfortable. Don't say the software is error-free. That's computer language. The software is stable. Let's see similar example in code. This is something that we could expect to see in a front-end template, particularly it's AngularJS. We have a button, and this button will be disabled if the application is not active or the application status is not 6. Forget about the use of magic constant 6 now. Think about the logic. The application is not active or the status is not 6. I am already lost. I have no idea when the button is going to be enabled. Let's try to reverse the logic to make it positive. The button is going to be enabled if the application is active and the status is 6. Much better for my monkey brain. I now know both when it's going to be enabled and disabled. But I almost hear some of you screaming, Nikos, Nikos, Nikos. Sometimes if we reverse an if, it is easier to understand it. For example, if the user is not logged in, return. Yes, I agree completely. So let's broaden up our rules. If a logical expression is hard to understand, try transforming it, the elements of programming style. It's only Hemingway that wanted to avoid negation. We are more lenient on that. Actually, this rule, be positive, not negative, is one in a set of rules that his editor, his newspaper editor, gave to him when he was a young journalist, a junior journalist. These rules really impressed young Hemingway, and he said, "Those were the best rules I ever learned for the business of writing. No man who feels and writes truly about the thing he's trying to say can fail to write well if he abides by them." These are some bold words, and he used these rules in his writing. But here we can see that even Hemingway had troubles following his own rules, huh? Did you spot it? He says, "No man can fail." But he should have said, "Every man will succeed." So sometimes we fail to follow even our own rules. We don't need to be harsh on ourselves, huh? Just aware. Let's move to the next point. Module length. The Kansas City Star, the newspaper that so much influenced Hemingway, had this rule. Use short sentences, use short paragraphs, or write in small units. What would we say? We would say, you ought to design your software systems as hierarchies of nested modules with the grain size of the modules at each level held to a minimum. Small functions, small classes, small packages. Of course, what small means, what is this minimum, is open to debate. How big should a chunk of code be is a big question, and everybody has a different answer. But there is also some fascinating research on the correlation between code length and bugs. Here we see a chart. On the horizontal axis is the number of lines that we're working with, module size. In this research, they examined a lot of different languages and a lot of different types of systems. So what module means for each one of these languages is relevant to the language itself. For the languages we are usually working with, and particularly for Java, we can imagine that module means function. So on the horizontal axis, we have the number of lines, and here on the line that says bug load, we have the number of bugs. And we can see that, of course, when we have 0 lines of code, we have 0 bugs. And that's why it's best not to write any code if you can avoid it. And suddenly it rises sharply, because we are humans and we wrote 10 lines, but we made errors. And it continues rising, but not dramatically, until a point at around 400 lines where our brains crash and we can't handle all this stuff anymore, and then it rises dramatically. So it shows a sweet spot where the optimal size of components, they claim they are at about 200 to 400 lines long. This shows that there is no benefit but only loss when we forcibly try to break modules down into smaller chunks. For example, imagine that you have a function that is 200 lines long, and you decide to break it down to two functions that each one of them is 100 lines long. You now have two functions to keep in mind. And the sum of the number of bugs in these two functions is going to be roughly double of the ones in the single bigger function. This is counterintuitive to the advice that we often hear. Small stuff, definitely not bigger than 100 lines, huh? One explanation on why smaller stuff have to seem to have more bugs per line of code is that, okay, a component might be very small, but it still has to do something. It has a large number of complicated connections, method calls, using variables that are defined somewhere else, using things that are passed to it through its argument list. And this increases the complexity of the component. Of course, we still have to keep proper architecture, division of responsibility, and all that in mind, of course. The way I understand this is don't force the breakup of the system in more parts than what common sense calls for. Some things are bigger, we don't have to force them to be small, and that's that. So, don't go on one hand where you have 1,000 lines of code and never think of refactoring. Of course, this is almost unacceptable. But on the other hand, don't be a fascist with these fascistic linters that block merges if a function is more than 20 lines, because these things exist out there in the wild. If you cannot trust your people to properly think about a function, or you don't have the resources to review their job, you have a much bigger problem, and the linter cannot help you with that. As programmers would say in the elements of programming style, modularize. Use procedures and functions. Break up your code in smaller chunks. Of course, they don't help us very much about how big or small these chunks should be, but considering that they wrote this book when unstructured programming and go-tos and 1,000 lines COBOL programs were the norm, then they were very much ahead of their time. So dividing our work in small chunks is a common consideration for all types of writers. Another thing that writers try to do is to avoid blabbering. Blah, 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 blah. Eliminate every superfluous word. The editor of the Kansas City Star was not going to accept anything unnecessary. The funeral services will be held at the hour of 2 o'clock on Tuesday. No. Funeral services will be at 2 o'clock Tuesday. And if we were putting this through a diff checker, look at how many things we managed to eliminate, or he managed to eliminate. Don't you love this feeling, by the way, of deleting all the unnecessary things? I get so much rush out of this. And how often don't we read code that is like this, has so many unnecessary keywords, tokens, long names. It goes on and on, blabbering about things, and we're thinking, oh man, will you get to the point? Let's see an example I recently worked with. This is again in PHP, but it does not matter. We see these things all over. That's a really big line, huh? And much of it is just blabbering. Let's break it down a little bit. We have a function, a method call that is completely unnecessary. It just happens to be in that framework. We then also have a class name that is blabbering too much. This thing truly is an application It's not information about that application. And every a repository is there. Every ORM seems to have a convention that there is a function called find that works by an ID. We don't have to blabber so much that we're finding something by the ID. When we remove all these unnecessary things, we reduce the line to almost half. Now it's a nice little line that I can read without getting scared, without yawning, falling asleep, or reaching the end and forgetting what the beginning was. Or, as the people from the Elements of Programming style would say what you mean, simply and directly. And look at how simple this quote is by itself. They don't even say write, code, functions. No, say what you mean. It's almost as if it is completing the advice of the newspaper editor. Eliminate every superfluous word. Say what you mean, simply and directly. It is as if it is one phrase told by one person speaking about one topic. And of course it is one topic, writing. All this blabbering now is something that many of you, since this is a Java-centered conference, I guess have encountered to a big degree. All this verbosity, not of the language, that has its reasons, technical reasons, but of the community, or at least of the community and the tools as I experienced them 7 years ago, the last time I seriously worked with Java. You know, or if that's still not the case, you remember all these abstract factory managers, like, come on, man. I know it's abstract. It's in the keyword. You don't have to put it in the name too. And you don't have to push the pattern that you're using on my face. Oh, you're using the factory pattern. Congratulations. But you don't have to put it in the class name. And it's a manager. What exactly is it managing? Surely there can be better names for these types of classes. Surely we can find better names. So be short, be to the point, be bold. You don't have to follow the conventions of prefixing or postfixing every interface class with interface. It is an interface, everyone knows that. Probably it's the implementation that needs to have a different name. For example, cache. We don't need a cache interface. Cache is an interface. You can have a file cache, you can have a Redis cache, and you can just call it file or Redis because it's in the right package, it's in the right directory. So be short, be to the point, be bold. Don't talk more than what is needed. But when you do talk, all right, be clear. Which brings us to the next point, one before the end, clarity. Clarity, speaking and writing clearly. If you know something, say it. Again, an advice from the Kansas City Stars, an advice for journalists. Of course, journalists are concerned with transmitting information, but this is also what we are concerned with, transmitting information to our fellow readers. If you know something, say it. Don't say, a number of pens were stolen. What number? Do you know the number? Are you going to tell me the number? No, you don't. So say, several pens were stolen. If you know the number, specify it. Don't throw their number and then have me wondering about numbers. Use the appropriate phrase. Don't write things that create more questions than answers. And how many times haven't we read code like this, a weird function, a weird loop, some weird function names that create so many questions? Why is it like that? Has it been maybe something like that in the past and someone didn't refactor too well and some remnants remained? Or someone thought it could be like this in the future and left these hooks there. And then you go, you ask some managers, has the business ever been doing this, or do you ever plan to do that? And they say no. And you are left there wondering, but why is the code written in such a way? Some other times you read some code and it's like doing some archaeological excavation. You can smell, you can feel all the different stages that this code has evolved through, but they're still there. They haven't been refactored away. They create questions. Are they really still needed? So don't write things that create more questions than answers, huh? And simple examples of how we do that in code. Elements filter. This is some JavaScript. Filter an array of elements. Elements filter. What are these elements? Do we need to go hunting around the code to find out? Ah, they're buttons. Buttons filter, much better. Or again, some PHP. The entity will be whatever the repository will find. What entity? What repository? A user will be whatever the user repository will find. Some of you now might be thinking, oh, well, but if we were using Java, that would be so much better because we would have the type of the user, the type of the repository. Yes. But this is just an example, a source of confusion, lack of clarity is not only because we don't know the type of the stuff we're working with. Imagine another example. It might be because we do not know why we are doing something or what exactly we're doing. Some better function names or variable names will solve that problem. Or it could be a function that is getting more parameters, that's having more parameters than what it is truly using. This is misleading, it's creating confusion. So the language and its capabilities can only help us that much. In the end, or in the beginning, it is up to the programmer to write good code. The language can't really help us that much. So that's just an example. What do our friends from the Elements of Programming Style have to say about clarity? Something really interesting. Write clearly. Don't sacrifice clarity for efficiency. And I love how they put efficiency in quotes because it's not real efficiency. It can be any kind of efficiency, huh? Oh, but this one letter variable is faster to type. I have heard that. I have heard this as an argument of why somebody was using one letter variables. It was helping him be efficient. Or the most common one, resources efficiency. Someone thinks that they can save a few milliseconds if they do something in some weird way. How many milliseconds? And does anyone care about them? Think of how in 1978, when computing resources were hundreds of times less than what they are now, even then, these people knew that the truly finite resource, the one that we must protect, is not RAM or processor power, it's our small monkey brains. It's our own stupidity. But after all these years, we still have to have long discussions, with co-workers about doing it or not doing it in this cryptic new way that will make this one operation that happens once a day 0.2 seconds faster. In my experience, most of these performance discussions have very little to do with actual business needs, very few of them. Mostly they have to do with programmers' vanity, desire for I don't know what. So clarity in our writing is, for the vast majority of cases, more important than efficiency. Or as a person usually described it to me, what I consider as performance is reading performance, refactoring performance, understanding performance. not time performance. Most use cases that we're working with are performant enough already. Most, not all, but most. So let's move on to the last point. Chekhov's gun. What a cryptic title, huh? This is definitely not clear, but I will make it clear. Chekhov was a Russian theatrical writer. Some of you might know him already, especially if you come from Russia. Now, theatrical plays are traditionally divided in three parts, called acts. If, said Anton Chekhov, if in the first act you have hung a pistol on the wall, then in the following one it should be fired. Otherwise, don't put it there. Because as a user, point. Is anyone gonna use it finally? Or have I missed something? Has something happened already? Am I an idiot? As programmers, we also see that often, like this funny pattern, defining a group of variables at the top of the function, all together so they can huddle and keep each other warm at the long winter nights. And 50 lines later, they still haven't been used. They're still in my brain as a reader. I have to remember them as I read through this function. I expect to see them being used. Do you plan to use them sometime, programmer? Or the other common pattern with if statements. There is this if statement. I am reading the if body. It is 50 lines long. I am still reading it. I still don't know what happens in the else case. I need to have it in my mind. By the time now I will be in the else case, I would have forgotten why I am there. What happened? What decision did I take? Or, as programmers would advise programmers, follow each decision as closely as possible with its associated action. As Anton Chekhov said, don't disconnect things. If something happens for a reason, put this something and that reason close to each other. Our brains have limited capacity. Protect it. Let's see an example in code. You recognize this pattern. It's the Christmas tree pattern, a series of nested if statements. If the user is logged in, do some stuff. And then if the user has credits, do some more stuff. And if the user is premium, do some more stuff, else. I don't know about you, but this is outright stressing me. Let's say I am at the if user is premium body, at the third if statement. Not only do I have to remember why I am there, all the previous ifs, but I also have to remember to check how each one of these is exiting. Yes, okay. I am reading what happens if the user is logged in, and if he has credits, and if he is premium. But you still haven't told me what happens if the user is logged in but doesn't have credits. We have some unfinished business here, mister. And by the time I'm in the end, at the last throw, for example, throw not logged in, it's not entirely clear to me which case is being handled. Is it the not logged in, not has credits, not is premium? Am I going to count indentation spaces? Am I going to start collapsing things if I use an editor that can do this? We have managed to separate an action from the decision for that action, the throw by the if, by 100 lines and many other actions that are unrelated to this. Let's see how we can do this better. And of course, we can do this better by the early returns pattern. If the user is not logged in, exit or do some stuff. If the user does not have credits, exit or do some stuff. Of course, we know how to do that. But it is still so tragic how often we see code that is written in the first way. Now, let's remove all of the clutter again to focus on what truly is happening here for our brains. This is what is happening. On one hand, we have a long blob that no one knows where it starts and where it ends. The other is a series of small blocks independent to each other. They're visually friendlier and they're more honest about what they are. Three similar operations, visually similar. It's easier to read, to digest, but practically also to reorder or to delete completely one of them. This is like small paragraphs, each one doing its own job. This is meant for humans. So this was the last point. Closing up. All these points that are made are not groundbreaking. I'm not the first one to say these things, of course not. I am sure that many of you, hopefully most of you, try to write code like this every day. There is nothing new under the sun, as it's also written in the Bible. But it does require discipline and effort to write well, and practice, of course. And it's an effort that we should do. Not only because it has concrete benefits, but in my eyes, because this is our job. We are authors. And the main point that I wanted to make is we don't have to be thinking that we are doing something so special that we have to build our own world. Rediscover the wheel. What we do has been happening for millennia. We write. Simple as that. We face the same problems that other writers face, and we have come up with the same solutions. I would love one day to see people telling to kids, "Oh, you want to be a programmer? Then you must be good at language, at grammar, at writing, not at math. We have had enough of that." And this concludes my talk. I am sharing my contact details here, and I will also share them in the chat, if I could share them. I think, no, I'll do that. I think we have at about 5 minutes or maybe 10 minutes more. So, is there somebody that wants to pitch in with some comments or questions? Again, we have a 30 seconds delay, so I'm going to wait a little bit for that. I have to disagree. You can always put the stuff part into separate methods and keep the first track, so there is not always a need to rewrite it using the second approach. I definitely agree. So if you have a function method with a proper name that informs us about what we're doing, it's definitely easier to get an overview very fast. But still, I personally do not like it because it is forcing me to be moving more and more in the file. It is creating too many indentations and making me feel that we're doing too many stuff. There is another way where we can write it in a flatter way, and I personally prefer it to be flatter. Also, I am very much a fan of this approach of not separating the decision from the action. If do this, if do this, if do this, else do that, do that, do that. One of the actions, the positive action, is separated by the negative action. It's polar opposite, it's small brother, it's twin really, by many lines of code. Yes, but reordering will be harder as well in this Christmas tree pattern. Yes, I agree, Mihai. Yeah, I agree. Or deleting something completely. You have to delete both the if and the else that is very far away. Actually, let me. Can you see my face now, or can you see still the slides? I hope you can see my face. We still have, I believe, at about 10 minutes, so feel free to chat away. So apparently we don't have any project managers here and no one from the United States, because I asked people to talk about it, but no one wrote. Yeah, thank you. Thank you so much. What is state pattern? I don't know about this. I guess I have to Google it. But if you can briefly explain, it would be nice. Oh, let me share my contact details for a moment. That's me. If anybody wants to reach out for some proper feedback about this talk or for anything else, I will be very happy. Thank you, Chavdar. Of course, for some people, this is common sense, and this is how we have been mentored to program. But from my experience, the places that I have been to, of course, I might have been in the wrong places. In most of the places that I have been to, most of the people are either too young to be really thinking this way, or no one told them they should be thinking or could be thinking this way. So although these things truly feel and are common sense, they are surprisingly not practiced or not talked about that much. And truly something that I find fascinating is, why do people enter the universities and the world of programming from the, let's say, the practical side of school, mathematics, physics, chemistry, from this branch, electronics, engineering, instead of entering it from the humanities, the writing, the grammar, the Latin, the Greek part, the part that deals with language and meaning? That's a fascinating question for me, because we don't actually build the motherboards. Other people do that. We just think about the world and try to express it. The domain model, the flow of control, these are all things that deal with language. Mihai, definitely. And if you contact me, I will also be very happy to give you the slides and the notes for the slides as well. Nair, I will reference two books, The Elements of Programming Style. It is a book that, as you saw, got written a long time ago. Its structure is the following: small chapters, each one of them dealing with this mantra that we talked about, mantras. And then first the mantra, and then a couple of code examples, and also refactoring these code examples to follow the mantras. The problem is that the book got written so long ago that it is using some weird languages like algol or prologue, so some things like that. I couldn't read it. I could read the text, I could understand what they try to say, but not the code. But still, it is a gem just for the mantras. So I would definitely recommend this one. A much more readable book, also the code examples are in Java, is Clean Code by Robert Martin. A really nice book, a very comfortable read, and it is touching on many of these topics in a very nice way with code examples as well. And also, if you contact me, everybody, I will be very happy to give you the slides. You're right, Chevdar, and the way that I kickstarted my brain down that path was by being mentored by two excellent programmers over months. Code review after code review after code review after code review, until things got hammered in my brain. It's extremely important to have somebody experienced in your team. And I feel pity for the business people, managers, young CEOs that do not understand that by outsourcing something to some remote country with low paying wages to people who don't have that much experience is not going to give you good results. Thank you very much, Nair. I will definitely look on that. State pattern. Context. It looks interesting. I will definitely give it a look. It smells like something that has some very particular use cases. It's not something that we would just simply replace an if statement with it for fun. It sounds like too much work if you truly have a business case that is screaming about strong starting points, strong ending points, and need to change these things comfortably and know where to find them. It's really interesting. I have never seen that before. Okay, I think we're going to conclude it here, and I'm going to say goodbye to everybody. I had a lot of fun talking about it, so thanks for listening. And once again, reach out if you feel like that. Thank you so much. I will now try to close it, but I don't entirely know how to do that.
Hello and welcome to the last session. The title is Evolving with Java, How to Remain Effective. I believe you had a lot of good sessions in the conference and learned a lot. In this talk, I'm going to summarize what I learned by evolving with the new versions of Java over last 15 plus years. My name is Naresha, and I help teams to get better with their technical practices so that they can improve their productivity and deliver better business value. This year is something special for especially for the Java developers, as Java has been here for over 25 years, and that's a long time for technology. And many of you might have been working with Java for several years, and some of you might be relatively new also. So in this presentation, let me share my experience or my journey with Java. Java has also evolved, and I got an opportunity to, several opportunities to work on Java in the last like 15 plus years. A good practice is always to start with the why. So let's do that. Let's talk about the business value. Of course, as developers, it's very important for us to deliver true value to the business. Otherwise, there's no way for us to survive, right? Of course, you understand what is important for your business and deliver that to the users and the customers. In today's presentation, let's understand how we cope with the change from the technology side. Change from the business side, something you know already how you cope with. You know your business very well. So let's focus on the technology aspects today. First thing is of course, you are able to deliver your application, say without defects, but can we deliver features faster, right? Can we reduce the time to market, or can we, increase the speed of delivery? That's an important question we have, and all of us are trying to improve on that. Of course, we know time is money, but on the other side, we also try to optimize so we can save cost. How we can develop quality software in reduced cost. That's also an important focus we are trying to do. So let me show you exactly one example from the modern Java, so that I can illustrate how features of modern Java cater to these qualities. Right? You take there are two pieces of code here, what you see, and which are mostly doing the same thing, but the main difference is that the first piece of code is executing sequentially, whereas the second piece of code makes use of parallel streams, and hence the computation can run in parallel. Notice the difference, right? It's a very, very small. So what you can understand from here is that the structure of sequential code is very much same as the structure of parallel code, right? So for some reason you believe parallel stream, making use of parallel stream is better, and you switch to that. And since the entire stream usage in your application will make use of single thread pool, what might happen is that some other part of your application might be starving if this part of the code is busy executing. So while parallel execution is really, really good from the throughput perspective, is it really good from the perspective of getting responsiveness to all users? That's a question. So in that case, say even if you want to switch back to sequential execution, you can do it really faster. So that of course, you're very quick in switching between these two modes, and also you can be the since the structure is very much same, you're not going to put a lot of effort in moving to parallel stream or converting a parallel stream of code. Just if you're familiar with the thread based code, you can imagine how that code would look like. So I believe from that you understand that modern features from Java can really help you to be more productive. With that, let's start our journey. Let me start by sharing the story from early days of my professional career. So what used to happen is this statement might be very, very familiar to you, right? Often we want to log something. So this is how you would create an instance of logger. In this case, I'm using SLF for J. Though in the initial days, it was more of log4j or any other variants of that. So what we used to do is, like, typically what I had done was like, when I created a new class, I had copied this statement from the previous class. As a result of that, my new class is logging with the name of the old class. So I'm not able to not able to retrieve the log what I was looking for from the log files, because it was copy pasted. Not because of that, it did not have the original, I mean the newer class name. I spent more than 4 hours or so, and I couldn't figure out anything, and I called it end of the day. And the next day, I could quickly figure out that this was the mistake I had done. Then, interestingly, what I did is I used the IDE template. You could create a template in your IDE, and with that you could supply key and auto generate the code for the logger, something like this. This is just for a demonstration purpose, even though originally those days I was using Eclipse as the primary IDE. So I just thought about this, right? I was very much familiar with this feature of the IDE. However, I had not put any effort to set up the template in the IDE. It is after that, spending 4+ hours, that I decided to make use of this, right? So it was that pain that caused me to take some genuine action. With that, let me introduce a model that we can, all of us can make use of for evolving evolving our code base, or adding making things better, improving our life, right? At least to trigger action. But let me start with a disclaimer. All models are wrong, but some are useful. So if you really want to prove that the model is wrong, you may be able to find some example for that. But the idea is that we find some motivation to trigger some action. So pain. What do you think about pain? Is it good or is it bad? I'm sure people might be thinking, okay, pain, why would it be good? It's bad, right? So let's make it good. How do you make it good? We put pain along with the suffering. Now say you choose pain or suffering, what are you going to choose? Of course, pain may be better, right? So if you just touch a hot plate or fire, immediately you'll pull your hand back because of the pain, right? If you don't do that, or if you don't sense that, eventually you may be hurting your organs, which is not good. So in that way, it may pain for a while, but still pain triggered some action. In that case, of course, it was a reaction, not necessarily a planned response. But that way, pain can help us to trigger some positive action. That's the key thing. So if you look at the example I mentioned before, it was the pain that triggered some action from me, even though I knew how to solve that problem beforehand. Immediately, you may have a question. That's okay. I have not experienced the pain yet. What should I do? Of course, you can rely upon your friends who have, been working in the technology or in the same application for a long time. They would tell you how they would share their experience. Okay, this is what I was trying to do, and these are the, these are the areas where I really have to struggle to get these things done. So you can rely upon somebody who you know to get the pain of the previous way of doing things. So that's how whenever you learn a new technology, either if you have experienced the pain, you would readily embrace something that is newly available, or if it is not, before you implement, before you adopt those features, make sure that you ask a question. Okay, what would have been the pain that triggered this feature, right? Triggered the development of this feature. You can ask the same question, for example, like maybe JPMS, Java Platform, module system. Okay, now certain things library developers wanted to keep private, but then people used all those APIs. Now they cannot change that. That's one of the motivations or one of the pain points people had, which is addressed by JPMS, right? Similarly, you could ask like the newer features like records, for example, what triggered that. There was a lot of effort in, you had to write a lot of, verbose code, right? Overriding equals, hash code, and so on. So now these, records make creating data classes much simpler, right? That's how you could use this pain principle to drive action and evolve. With this, let's take a few more examples from the evolution of Java and see what else we can learn from, right? Beyond moving from one version to other, what in general we can learn from these, moving to newer versions. Interestingly, string concatenation is an area where you can learn a lot. And let's take this simple example where I'm using a typical plus concatenation operator for concatenating, but then, you might have, if you are working in those days, you might realize, okay, there were articles explaining, okay, this might not be a great idea because string is immutable. And every time when you do this new string instance gets created, and maybe using a string buffer is a better idea because, conversion to string happens only at the end here, right? That was one of the, reasons. Now let's see, we followed those instructions, and the so-called best practice you embraced, and you use string buffer instead of plus. Let's see what happens, right? So this is what happens in string. This is a JDK 1.4, right? Wherein you use string buffer. This is for the first one, actually. Using the concatenation operator plus, which also under the hood will use string buffer. Only the additional is that every time it will get converted into string, creating an extra string object. But now the same concatenation code, when you compile with the Java 1.5, see, it uses, instead of string builders, another class called, instead of string buffer, it uses string builder. String builder is functionally same as string buffer, but string buffer was thread safe and string builder isn't thread safe. But since we are using it in a, as a local variable, we don't care. We don't have a shared mutability problem here. There's nothing shared. So mutability is not a concern for us. So string builder doesn't do anything, right? But so we get some performance benefit with the string builder. Now you would say that, okay, people who are aware of the best practice, they did something, and people who are not aware of the best practice, they didn't use string buffer. Instead, use the concatenation operator plus, and now the one who gets benefit is the one who did not embrace the best practice. Oh, this is very bad, right? You really want to cry, because it's like punishing the punctuals, right? Who people who come on time and say, okay, let's wait for everybody else. That's the kind of feeling you would have had those days. So let's ask this question, like what code is more maintainable, and what we can learn by going into this and exploring this a little bit. So let's compare plus versus string buffer. I mean, it started with string buffer. Right? So level of abstraction, concatenation, you would see is slightly at a higher level of abstraction because plus concatenation operator gets converted into string buffer or string builder, depending on where you use. So concatenation, of course, is the API. They are pretty much compatible. However, string buffer also has an additional responsibility of thread safety, which we don't need at most of the time when nothing is shared, right? Local variables are not shared. So it has additional responsibility. However, the concatenation has a higher level of abstraction. So what we can learn is, by favoring higher level of abstraction, you might end up with the less maintainability, less cost of maintenance. Whereas if you get into lower details, there is a potential that you may have to, end up incurring more cost or effort for maintainability. This is in general, we have to take it as a general rule. Of course, there could be exceptions to this. And also, a related principle is premature optimization is the root of all evil, comes from Donald Knuth. And the reason why he was talking about is that people often, try to optimize small parts of the program which might not be widely used, right? For example, say if you have a method that gets invoked, say over the month, and that too when some admin user logins and does something, if you improve, say if the method takes 1 second and you reduce it to half a second, it might not make much difference. Whereas you have a certain method which takes say 500 milliseconds but gets invoked by several thousands of users every second. Even if you improve it by say 100 milliseconds, I think you're going to get a huge benefit, especially if you're operating in a large scale. So I think you understand that, and we can make a trade-off by comparing what is the effort and what is the return on investment we are going to get. But in general, higher level of abstraction may be a better approach, or at least that's where we should start with. And here is the rule for optimization. The first rule says don't optimize. The second says don't optimize yet. And rule 3 says profile before optimizing. So you profile your application and understand where is the real bottleneck, so that you get a real benefit of optimizing. And you have the link below for that. A related part when you are going to spend effort is like Yagni, you ain't gonna need it, which is closely related to simplicity, because simplicity is when there is nothing else to remove, right? Nothing else to add. So you ain't gonna need it. Probably you don't put whatever is not necessary, so that you don't make things complex unnecessarily, or you don't end up increasing the complexity unnecessarily. You realize that okay, there is a genuine need for certain thing here, whether it could be optimization or it could be dependency and things like that, and only in that case you go and add it. So what I really like is make it work, make it a better approach, which is which is typically known as iterative approach, right? And a related rule is like make it work, make it right, and make it fast. Make it fast comes at last, which you keep on iterating. Last bit from the concatenation. So we have seen like what happens with the Java 5, but in Java 11, if you compile the same concatenation code, you would see that it invokes invoke dynamic, which was added later, right? And it calls this make concat with constant. This code, which is invoke dynamic instruction, was added typically for dynamic languages to run on JVM. However, interestingly, Java 8 was the first language to take a real advantage of the new invoke dynamic VM instruction. So in the previous rule, we saw how iterative development is much better, or is the right approach. I'm a great fan of test-driven development, which helps in keeping the Yagni principle, or striving for simplicity. Though I'm not going to talk in detail about test-driven development, I do want to focus on one aspect, that is refactor. Right, refactor is a behavior-preserving transformation, so which you always do on a green state. Right, you make sure that all the tests pass. Then you change the structure of the code, which is essentially changing the design of your application without impacting its behavior, right? So after you refactor, now the structure is changed, design is changed, and you still ensure that it is in green before you want to add more features, which essentially means you have to write a failing test before that. So when you evolve or you embrace new features of Java, typically when it's a good time, or typically when is a good time to refactor. One is once you implement something, oh, it's working, ask, is this design adequate, can I improve that? You refactor that. That's one way, right? Another is, okay, you have done that, you are going to start with the new feature, and now ask that question, is the current design good enough to accommodate the new feature, right? If it is not, you ask the question, okay, I'm in a new version of Java now. Is the design going to become any better by adding this new feature, or refactoring to use the new feature in the current features, right? In the current set of application feature I'm talking about. So in that case, you can go ahead and change your application, make use of new features of Java, then add the new business features. That would be a much better approach, rather than saying that, okay, now there is a new version of Java, let me go and add all the features one by one. That may not be a good idea. So in this case, over a period of time, you will really reap benefits by using new features of the language and tools, by using the right refactoring technique. Another important aspect in this, like you have a method here, like get orders of customer. You would often see methods like this, which returns a list. But the question comes is, typically, like you will have an interface, and then there are one or more classes implementing this interface. So just by looking at the interface, I don't understand what of course I can say that it returns list, but what does the list contain? What is the type of the object this list contains? It's hard to determine from looking at here. I'll have to go to the implementation to understand that, which was one of the main problems I was facing when I was working with like Java 1.4. And you would say that, okay, why not we put in the comments? But to be very frank, most of my enterprise application development, I have not found any useful comment most of the time. You should be thankful if the comments are not outdated and misleading. Most of the times people change the code but don't change the comments. That's very common situation. However, you can't even trust the comments blindly. So reading comment was mostly useless. And of course, you will have some redundant comment saying again the name of the method being duplicated there, etc. So in this case, generics really, like from Java 5 helps. Okay, now I know it's a list of order. I know how to use this without having to read all the implementation, the code implementing how to retrieve these methods, right? Retrieve these data. So that's kind of helpful. Or sometimes if it is returning order or order summary, I can know very clearly from the method signature, which is of course compiler has to validate that, which is the benefit you get. So it's a kind of self-documenting code. Next, let's take a look at this again. It's from 1.4. At this point in time, you're using an iterator, which has few risks of like it has too many moving parts. And once you use the iterator, there is a risk of reusing this iterator. So you end up writing the code which is less verbose, and again which is at one level higher level of abstraction. However, if you look at the bytecode, you understand that it is still using the new for each loop, which is still using the iterator under the hood. So it's more or less, it's a syntactic sugar. Now you understand that there is a level of abstraction at JVM, and there is a level of abstraction at Java, the language level. Now, something can be added at the language level without needing extra support or reusing the same thing what JVM was using before. That can also help developers. This is a principle used by several languages other than Java that target JVM. So what we need to understand from here is that minimizing moving parts can significantly help reduce defects and improve the readability also. Another code which is imperative, and let's say we are using the streams API here. Again, when we see this, there could be initial inertia to move from the imperative code to the code at like Java 8 streams code, because it requires a little bit of understanding of how it works, or at least some basics of functional programming would definitely help here. However, if you notice that the code below, the older one, is the different concerns are all interweaved, whereas those concerns are separate, which makes the code more readable in the newer version. Also, the newer version or the Streams API makes it more composable. Now, if you want to add an intermediate filter, map, or any operation, which makes it much easier. So with the small cost of learning the functional paradigm, we get the benefit of more modular code and more composable code. Also, an important factor is like the code also happens to be declarative code, though functional programming is not the only way to have declarative code. You could also use sometimes like say an annotation based approach to make the code slightly more declarative, but you may not get the benefit of composing in annotation based APIs. And it's also important that you learn multiple paradigms which can really change the way you think. Again, when people started with the object-oriented paradigm, procedural paradigm was quite popular, and I have seen like people would always fill a class with too many details, not having enough classes, not having enough modularity. The only reason why people would use classes is to make use of inheritance, which is also not right. So that paradigm inertia we saw when there was procedural was mainstream and people were migrating to object-oriented paradigm, And similar, inertia may be seen when you're, moving from, object-oriented to functional. By moving, I mean not throw away object-oriented and move to functional paradigm. You embrace the newer one. So, and interestingly, it's always the first time you have the maximum challenge, right? You will always think in the old paradigm way, and your brain resists to think in the newer paradigm. Once you cross that boundary, it takes a while. You put that effort and cross that, then of course your code is much better, your design is much better, and interestingly, learning the next paradigm becomes much more easier. It's the first, it's the second programming language which is hard to learn, right? I'm assuming like there is a paradigm shift also, not just a syntax difference. Now, usually what, looking at this code, it would look like, I'm doing the filtering all the even numbers first, then I'm squaring all of them, then I'm just finding the first one. So I just need one number here. Why should I waste all my, time squaring and, filtering all the numbers from the list is the question typically comes. But under the hood, streams execution is interweaved, even though at your level it's all separate, but it's interweaved so that in effect it's the same as what the code you would write below. So what happens here is that what you see is not what you get. Just by looking at the API, you can't understand what is going on under the hood. So what's always, lazy evaluation is the benefit you get, but what's very important here is you understand one level below the abstraction you are dealing with. Of course, if you could understand more layers below that is good, but it's at least one level below you are operating with is something extremely helpful. And it might be extremely hard to go all the way till the hardware, because usually these days you may run the application in a container which runs on several layers of virtualization before reaching hardware. So I can totally understand how hard it could be. You don't have to do that. Just one level below the layer you are dealing with can always help. You never know when you need that. Let's see how sometimes, even though Java has evolved, certain bad practices or certain bad decisions, or certain decisions which were right in a particular context just spread everywhere. And Java Beans API is something I would specifically want to point out. In this case, it's a code from the Bean introspection, introspector.java of JDK. You see that how it still has a reference to java.awt, even though AWT has got nothing to do with in the sense it shouldn't have been truly coupled, right? Of course, Bean's specification was really useful for you have a GUI component which has to set and get several properties of a class. In that case, get something, set something. That convention was really useful. But what happened is the side effect of that was people created classes with every field having getters and setters, throwing away the principles of encapsulation, which resulted in a very, very bad code. So let me show you how typically, people who are highly influenced by, Bean specification write the code like this. So you would say you have create a new instance of pizza and you want to give that to a friend. You'll say like friend.getMouth.set food, all, the violation of Demeter, the law of Demeter you might be aware of. So what's a better, so don't ask, right? That's the Demeter principle. So here you say friend.offer food, which this is a much better way of representing this, so that offer method has all the details of whether it should be fed to mouth or whatever, right? That's how that's the encapsulation what you need to understand here. One of the main, I mean, today we see a lot of object-oriented bashing, but at the same time, people of all good features of OO. I still think OO is relevant. It's pretty useful, though I'm not saying that OO is the only good thing in the world. Of course, you have good things in other paradigms as well, and depending on your context, you can take advantage of one or more, especially since languages are multi-paradigm today. You don't have to go to multiple languages to make use of or take advantage of multiple paradigms. So that was about encapsulation, and interestingly, over a period, we have learned that checked exceptions don't do something really great. Even runtime exceptions, with the runtime exceptions, you can achieve this. I don't have a good example, but I believe that's fairly evident. It's like initially when I started my professional career, we had version control systems that were using locking, right? So somebody would lock and keep, then you will have to, I mean, it's you feel great when somebody comes to you, hey, could you please unlock that file or release that file, right? But at the same time, when you have to work and some other developer has a lock on that, okay, then you have to go and beg him, okay, please release the lock. And that's not a good experience. But and especially with the open source spreading, we realize that you don't need that kind of control, right? People can behave well, and with the coordination, you really don't end up breaking things, right? That's something we have learned all the way. The same way here, if you force people to write exception handling code, they'll just way back I had code, it was a library which people asked me to use in the enterprise. Hey, this is a new library we created which can parse XML and all. Interestingly, when I opened the source code and saw that they had empty catch blocks, even so if it fails to parse XML file, I wouldn't even know that it failed, which is really dangerous. So that's not the way to go about it. We have learned that. And an interesting part is like Java, today is a platform, not just a language. Even though when Java was started, it was a single language, multiple platforms, multiple OSs. But over a period of time, it's like multi-language and multiple platforms. So today, when I say Java, I really refer to platform. So I think I like a decade ago, I gave a presentation that Java beyond Java, to convey that Java is really a platform, not just a language. That was like a decade ago. And it's not just me, James Gosling, who has been attributed as father of Java, also acknowledges the fact, that, he also says that you may be surprised to hear this from me, but at the core of the Java ecosystem is the JVM. And you could see multiple languages started with, Scala, Groovy, and, Kotlin, and there are many more languages which are targeting. And we have here, TOB index. I wouldn't say that TOB index is the place to look for popular language, but it's one of the a place which ranks use of languages across repository and all. You could go to their website and read more about how they do it. But then you would see Java is at number 2. The Groovy, which is another JVM language, which is at number 11. And there are other languages like Scala and Kotlin are also quite used on JVM these days. So with that, let me move to the multi-language aspect. So if you're using Java platform and you're developing application, I think going for other languages is a good option you have. Even if you're not using them in your production application, it's always good to learn at least one of them. Let me show one of the examples here. So in this case, I want to generate 2 string, right? So usually what you will do is you will go and use your IDE and say generate 2 string method. It will generate 2 string method. It's fine. Then later on, what I will do is I'll go to the class. Hey, I have first name and last name, 2 fields here, and I may need, okay, let me add date of birth and a lot many fields. What happens to your toString? It is still relying upon only the 2 old fields, right? It doesn't get updated automatically. So one thing that what I realize is that those practices which think that code is written once are all not good for software development. The good principles of software development are the ones those realize that code evolves continuously, right? So in this case, toString is generated by compiler by putting this at toString AST transformation of Groovy, so that every time I add a field, obviously you'll have to compile, and compiler will generate that code. So every time your toString method is consistent. You would see how the corresponding, the equivalent of Java code, which there is that at generated, which shows that this is synthetic method. Similarly, you could put, say, immutable. In that case, I can't set anything, or say I say me dot first name actually calls the setter, not just the field being public. And similarly, you need to generate the getter here, which is also generated by the Groovy compiler automatically. All these are some of the advantages, of course, which can come to Java also. The equivalent in Kotlin is this. It's typical data classes. In Scala, you would say case classes, which is also immutable, which will generate hash code equals, and you're having of course the records, which is doing something similar, which is in a preview mode. So you can always, even before the features are GA, you could always learn them. And especially with the Java, becoming in the 6 months release train, I would highly recommend moving from one LTS version to another LTS version for most of the production application, unless say you have a smaller microservices kind of thing where you can always experiment and move on quickly. But it's a good thing that you can always try out the new features, and you're ready, you are well aware of the features, and when finally you have it in an LTS version, you could make use of that. And if you want to use it in Java today, of course, you have Lombok, which is doing something similar. You could see that all these classes are generated. So yeah, multiple, you can always learn multiple languages. Of course, I wouldn't confine it to JVM languages. You could learn any of those languages, even if you are not going to use those languages for your day-to-day work. The way you think will tremendously change. And I'm sure if you learn say for example Haskell, the way you write your Java code is going to change a lot. The way you think improves tremendously. And let me move to the final section here. That is where we talk about a little bit of feature abuse, right? Just because of there is a newer feature, you don't have to use it. So in my list of most abused features, the number one goes to inheritance, right? When you have a hammer, everything looks like a nail. So inheritance, okay, I have a class which has some functionality there. Why not say, let me reuse those functionality here? Okay, my class extends that class. That's not the real reason for using inheritance, right? Inheritance is for Liskov substitution principle, right? Client has an interface. Okay, this is the contract now, and whichever class implements that, or the variants of that, you can always have inheritance from a class to multiple other child classes, not really to make use of reuse or something from the base class, which may be that I understand that there is a genuine problem, maybe deficiency in the language, but otherwise you should not be using. It's like we might have seen like 3D extending 2D, a lot of wrong examples out there. Though and we know that favor object composition over class inheritance. We have heard it from Gang of Four and from Effective Java, all these places. But often it is the most abused feature. The second in my list is default methods. Interestingly, the biggest user base, or the one who really needed the default methods, are the Java standard library developers. If you're maintaining a library, then there is a small chance that default method may be helpful. And if you are an application developer, then I don't see any reason why you should be using default methods. So previously we had this separation of concern, right? Interface is like a contract, and now implementation has the all the implementation details there. So interface was purely a contract, and the reason why this gets mixed up is in the modern frameworks we follow the philosophy of convention over configuration, right? So by default, this is the implementation. This is how error gets handled. This is how say cache did not have the data, how you intercept that and it gets handled. All these are kind of default supplied by the framework, but those need not be implemented as default methods. So the real disadvantage is that when you as a developer have to implement that method, okay, now compiler will not complain you have not overridden default method. So whatever is the implementation is not a conscious decision by you. If you had to implement, okay, now how error should be handled, or should I ignore it, Boolean true or false, as a developer you would make a conscious decision. Now you're not doing that. And I was going through the source code of some famous open source projects, and I saw a lot of, even which is developed by some of the great developers in the world for sure. However, things got mixed up there, which is not good in my opinion. So it's very important that these features we have to use judiciously. Just because it's there, don't go and use these features. With that, let me say that, okay, ask the question why this feature is there, why you are using it, or if you have already experienced the pain, you will readily go and embrace that solution. I'm sure that, right? And strive for simplicity. Most of the time we think familiarity is the only way to deal with simplicity, right? Because you are familiar, you are able to handle that. If you're not familiar, you're not able to handle that. That's the typical approach. But by using the principles, whatever we have seen before, we could make sure that we could achieve simplicity, not just with the familiarity. Of course, you can always break that familiarity ring, learn more things, right? More modular code, encapsulation, make it work, make it better. All are applicable here. And with that, I would say that the true nature of code is evolution, right? Anytime you may look at the code, you just see the snapshot. You don't understand how it evolved. So if you really want to be a good developer, and the best way to learn is pair with other developers, or you make use of mock programming, and you see code evolving from one state to another, learning that, evolving that, the experience of, or maybe you are having a pet project for several years and you evolve the code all this time. The experience you get from there is truly helpful, which is quite different from looking at the finished code. So I would highly recommend you to embrace pairing with others, or mobbing with others, do like code retreat. All these kind of things can really help you to become a good developer with a lot of deliberate practice. With that, I would like to thank the organizers for organizing this amazing conference. I'm sure it has helped so many of you, especially being in this online mode. And I hope I managed to give my 2 cents to the community. And if that you learn something from that and save some time for you, that I'll be really happy about that. With that, any questions?